We've been asked to find the integral of cos of 5x dx. So the problem we've got here is that we've got a function here, 5x, and then we've got a second function, cos. So this is a function of another function. And the way we deal with this is to use integration by substitution. Now a good tip, this won't always apply, but a good tip is you substitute for the bit in brackets. Okay, so that's what we're going to do. So we begin by saying let u equal 5x, that's the bit in brackets, and then we differentiate that, so du by dx is just going to be 5, and then we rearrange that equation so that we get an expression for dx. Okay, so going back to the top, we started with the integral of cos of 5x dx, and we've said u is equal to 5x. So our question now becomes the integral of cos u dx. But now we've got another problem. We've got a mixture of variables. So in other words, we've got x here and we've got u here. So we need to get rid of the dx. And that brings us back to what we did a moment ago. We just worked out that dx is equal to du over 5. So now we can rewrite this bit as the integral of cos of u du over 5. So all I've done is replace the dx with du over 5. If you prefer, you can rewrite that so that it looks a little bit tidier, like this. And then we know that cos integrates to sine. So this just integrates to sine u over 5. And then because we don't have any limits here or here, this is an indefinite integral. So we have to put the plus c on the end. And then we're not quite finished, because if you go back to the original question started with x is in. So we have to finish with x is in this particular case. Okay, so sine u over 5 plus c is what we've got so far. But remember, we defined u at the beginning of the question. We know that u is equal to 5x. Okay, so all we have to do is rewrite the u as 5x, and then we have our final answer, sine of 5x over 5 plus c. If you want to tidy things up a little bit, it's conventional to write it as a fifth sine of 5x plus c.